Hi, everyone, and welcome to the PolyAI podcast, where we'll be exploring topics like generative AI, voice AI, and the whole conversational landscape. We'll have interesting topics and interesting guests for you each week. And I'm one of your hosts, Michelle Schroeder, and it's my job today to ask questions to our expert co-host, Nikola Mrkšić, who has a PhD from Cambridge in machine learning and natural language understanding, was selected for Forbes 30 Under 30, and who founded PolyAI in 2017. So, welcome. And excited to get into this conversation. Cool.
Absolutely.
So I figured we'd start with a primer for outsiders. I think a lot of people are hearing a lot about generative AI, and this is after just a huge wave of news and sort of buzz around large language models. And while it's pretty safe to assume most people don't understand either, I think maybe if we just start by understanding both together, understanding sort of what makes them different. And I was given this semi-helpful model, and I want to know from you if it's correct, if this is a way that people can sort of think about this. So not all generative AI tools are LLMs or rely on LLMs, but all LLMs are a form of generative AI. Is that correct?
Okay. Well, to put my professorial hat on, generative models are basically one family of machine learning models, statistical models, really, which model what is known as the joint distribution of the data that they observe, right? And that broadly means that they're they're called generative because once they model the data that they're trying to learn, they're able to produce data of that kind, right? To generate it, right? That data could be text, right? And that is what language models do, large or not. It could be images, it could be something else entirely. It could be medical data, it could be all sorts of things, right? And data of any kind. The other family of models is called discriminative, and that's basically where you're not really trying to understand the substance, essence of that data, but rather you're trying to learn how to classify it. So say in medical data, you'd be like, is this an example of this virus or is it not? Is it in the case of text, it could be, is it an article about, sports or about politics? Generative models are really learning the structure of that data, right? So for example, with text, they would often be trained on things like Wikipedia or a data set known as Common Crawl, which is basically crawling the internet and just trying to kind of like ingest all that data and then reproduce data of a similar kind back. So language models are models that are trained through observing text, and they can produce text. They can continue a sentence if you started, or in the case of large language models, and what we've all recently been excited about is you can really create even autonomous agents from them, where basically you instruct the language model to behave in a certain kind, and because it's seen so much data. And in the case of things like GPT-3 and similar models, a lot of synthetic data that followed a certain pattern of conversation, then you're able to kind of like have a system that produces text in a conversation with you that is, very reminiscent of an actual human that you could be having that conversation with. So LLMs are an instance of generative models. There are different kinds. So when you look at, a lot of the stuff that was done, like, Midjourney and Stability and other models, like those were models for images, right? You could have models that jointly model images and text. You could have models for music, right? It doesn't have to be just text, but when we're dealing with text, then we're using a language model. And in the case of, what we're talking about here, we call them large language models simply because they're far larger and more impressive than anything we have trained so far.
Yeah. Tell me this. When you were getting your PhD and you were studying, and like learning about these large language models, creating these large language models, like, did you ever expect that one day you'd be able to give it some agency, tell it what to do, and have it sound human, have it actually generate a plausibly human response?
Yeah, so I mean, the problem operates at several levels, right? So no one really called them large language models until very recently, right? a language model is one of the first things you learn about when you do a natural language processing course, right? And I think one of the favorite gimmicks in most courses is, you could start something that sounds a bit Shakespearean, and you run the language model to predict the continuation, and you will get a few verses that really do sound Shakespearean, right? And in the simplest form, what a large language model does now is it's able to continue that a lot better, a lot more intelligently, holding kind of like dependencies, say in the poem that it's writing, referring to something that it generated. So it's all really impressive, right? Now, in terms of like telling it to behave autonomously and stuff, that was really a matter of the data that was used to train these LLMs, right? So people at OpenAI worked long and hard to create that kind of data and to create training procedures that were conducive to getting that kind of behavior. So like always with machine learning, big breakthroughs are not purely scientific. They're also feats of great engineering, right? And I'll say that what they've done with building GPT 3.5 and GPT-4 is probably an effort comparable in scale to, I don't know, building the pyramids or something like that. It's not all that easy to reproduce, which you see from the other models, and the fact that they haven't really yet matched that performance easily, right? So I think there's a lot of good, hard work that went into creating the data and the training procedures that they're using. It's not just that there's been a scientific shift. If you were to be a bit cynical about it, you could even say that there isn't really a major scientific breakthrough, and that the only real engineering improvement that happened is the use of transformers rather than, say, LSTM cells.
Yeah, cool.
Again, these are
Well, you talked.
building blocks of neural networks, right? So it's kind of like saying you have like a better building block in creating the whole thing. But the whole thing, we would have probably gotten there even without transformers, but it might have taken us longer, maybe substantially longer, maybe a decade or two, right? Maybe even more. It's hard to know at this point.
Yeah. Well, I'm glad Transformers came about. Given all of the progress that we've made just as a company, but also as a society with what's happening with generative AI, I think it's a lot of really exciting developments. One thing I did want to ask you is you talked about OpenAI and their sort of pioneering work, unless you look at it cynically and give a lot of that credit to
No.
Transformers.
It is absolutely. It is. I only say to put it in context. It is like groundbreaking. It is amazing what they've done, and the beliefs that they've had in putting the whole thing together and building like bigger, better things, improving the models, data, training, hardware. They've done an incredible thing.
Yeah. And I think I agree with you from a layman's perspective, but just given sort of recent developments with OpenAI, I think it was only a matter of time before they put a voice to GPT, before they allowed you to sort of interact with it from like a voice interface perspective. And I'm just curious, like as a person who's done a lot of pioneering work in the voice AI side of things, what you think about that. You mentioned on a previous podcast that you felt that voice was the most intuitive interface. Like, is this confirming or affirming of that to you?
Well, I mean, look, I think plugging speech recognition on one end and text to speech on another does not make, it does not complete the process of building a really good voice assistant, right? So I think that, OpenAI has done work on speech recognition. They recently announced that they're doing work on text to speech, and I have no doubt that they will be one of the main players building the best versions of these things, right? When you put it all together, it's still not the whole story, right? So, for example, what you'll often see when you interact with kind of like simple speech recognition plus an LLM versions of voice assistants is that speech recognition errors that happen will just be ignored, and there will be absolute confidence in how these models continue a conversation. So, if I said, hey, I referred to Michelle, but actually it's transcribed as Michael or something similar, like the model will just continue as if like I typed out what it had recognized. So that kind of like composite motion of knowing that the input is not perfect, that's something that the LLM is not yet primed for. So when you build enterprise applications, there's still a lot of room to improve in just dealing with speech recognition, and everything that goes wrong on that front. Because even prior to the advent of LLMs, the things that we have been building with voice assistants did not really suffer from, like, whenever we misunderstand something, it's not really due to our natural language understanding models failing. It's mostly to do with the fact that the speech recognizer just has not captured the right information, and we're unable to parse that from its output. So that's the kind of like big deal with voice. The other part, obviously, is like that whole thing. Like, what does it sound like? Is that generated voice from the text to speech model? Is it something that's good, right? And there, we kind of like internally at PolyAI for a long time have had two tests, right? One is, can I tell that it's a human or not? That's kind of like your Turing test equivalent. Um, and then the second thing is like, is this a really good voice, right? Does this sound like my best agent or someone as good as my best customer service rep? And they're two very different levels, right? A lot of companies out there at this point have text-to-speech models where you can't really tell, at least from a few words, whether it's a human or not. And they're getting really, really good, right? Um, but often, kind of like when you hear them, um, there's still there's a lot of room for improvement compared to just kind of like a human with good diction, prosody, and good expression, right?
Yep. Yeah, no, it's interesting that you mentioned the Turing test because I think there's some controversy over the past few years about putting these models to the test. Like, are they actually able to pass a Turing test? And like you say, voice is a lot harder, not just because of being able to sort of pick up what's being said and then respond to it in an adequate amount of time, in a human amount of time. It's also something else. And actually, this is a bit of a strange kind of aside, but I remember reading about some research a long time ago about sort of like humans' ability to tell if they're speaking with a psychopath. And it is relevant, I promise. But just the amount of emotion that the person puts into their voice, the inflections, sort of like where they choose to put in emotion and how. And I'm just wondering, even with the best sounding voices today, even with the lowest latency sort of conversations and sort of the best all of the things that need to go into a stack to make a good voice and to make something conversational. Do you think that there is AI out there that can pass a Turing test that can make people feel like they're speaking to a human?
Yeah. So, okay, the original Turing test isn't really phrased in terms of voice, right? It's really
Sure.
about like a text interface and language. And, there
Yeah.
are like algorithms, really, not even like heavily machine learning based ones, that have passed it, right, under these conditions or those conditions. And like what I think the academic community will tell you is that like the test is really not worth a whole lot because it's not really a measure of
Yeah.
intelligence. It's just a game to be gamed.
Sure.
And, once you give clear conditions, then gaming anything is quite easy, right? Like a law or a game or anything like that.
Totally.
So, um, like whether like the Turing test is the best thing to talk about is debatable, right? But while we're at it, when it comes to voice, I think what you would notice now with generative approaches is that the voice itself, depending on what you use, would vary. And, it would be enough to, the way you could call it out if you really wanted to kind of like port the test to voice is you could say, hey, would you mind like, saying my name is Nikola, not Nikola, because I'm not a British woman. I am a Serbian man, hence the style is that. Like the model will fall flat on its face because that level of control, say over stress on specific words, is just not there. And that's something that to us as humans, it's pretty intuitive. And my last name, we could go around in circles around trying to say Mrkšić. And if you haven't grown up in, with a Slavic language as one of your bases, you're probably going to struggle for quite some time. But we could have that conversation.
I tried.
Yeah,
I
it's
tried.
terrible, yeah. But it would be something that we could iterate on as humans, and I would know that you're human, right? Whereas, like, if a system just kind of goes and misunderstands it, and the typical speech recognizer will recognize exotic things like muffin, mattress. I once got Brexit recognized as just from the speech recognition. So, like, it's just not a word in the vocabulary of the language, right? And as humans,
Right.
we still have far more expressive models of how we represent things and how we like store them in our mind. We kind of like play back audio in a way that these things have just not been built to do yet. So there's a lot of depth in there. If we were to, people imagine a world where like these deep fakes are so convincing that people never stop and tell. And I think it's an important topic because if people are not expecting it, then they might never think to check, right? If it's
Yeah.
a scammer's call telling you that, I don't know, a loved one is in trouble and you're calling from a hospital or some nefarious scenario like that, then you might not just think to check. But I think as these things proliferate, and I don't know about you, but I get spam calls all the time in English and other languages, and I think it's just people will very quickly be able to kind of like throw these things off, and
Yeah.
technology catch up. But things like stress on words, there's a lot that can be done if you're expecting it.
Yeah.
We're
You
still
ask
pretty.
them to pronounce your name. I
Yeah.
think you know it instantly that it's not real. I know what's interesting, like just from a PolyAI perspective, is that you get these turns and these inflections and this expressiveness that does feel very human. It feels so human that a lot of our customers are saying things like "Thank you, have a nice day," or asking
Yeah.
about the weather, or like really trying to have a two-way conversation as though it were human, because most likely they're believing that they're speaking with a human. And I'm curious about
Yeah,
the
I mean,
the
sometimes they change their mind, right? Like we've had, all sorts of. Here, I'll tell you an example.
Hi, thanks for calling Bella Italia Telford. How can I help you today?
Book a table.
When would you like to come in?
Today.
What time do you think you'll be here?
6:15.
And how many people?
7.
Let me just have a look at what space we have. It looks like we've got nothing within 2 hours of 6:15 p.m. Is there another
Do you
date
know
or time I can check for you?
No, I'm so sorry. I thought I was talking to a robot, so I was being really rude. I do apologise. Sorry. No, that's all good. We're looking at it right now, so that's no problem at all. Thanks ever so much.
A very British reaction, but those things
Wow.
happen, and they either way, right? But it's very rewarding when you kind of like see something like that. Not that we designed
That's
for it. Like our philosophy is not to, trick people into thinking that they're speaking with a human. We want them to just not feel like they're speaking with a machine.
Absolutely. Yeah, that's such a cool example. And I'm just curious about the generative version of those types of calls. So I know we're still, it feels like, on the early frontier of a generative bot being able to sort of take that entire conversation and make it sound as wonderful as what you just showed, like as human, as expressive, as that sort of pause, that let me just look, that sort of feeling that you got from that. How far off are we from seeing generative be able to do a call that sounds exactly like that?
I think we're pretty close. I think that there's one piece just around like text to speech and how you do it. So what we use is an approach which basically gets a voice actor to record a lot of things, and then we synthesize things that we don't have in a very seamless way. We've found that to be the best thing we can do, better than a fully neural approach. Neural approaches are getting better and better. So there is more and more that can be done, and at some point, probably some point very soon, it's likely that we'll have convergence there, right? The other issues with generative are, I think people talk about it a lot. It's basically just the controllability. You won't actually get something very weird out of the model, a hallucination, right? An answer to a question that the model might be just kind of like freestyling rather than pulling from data that you've actually provided. Because these things are trained on so much data that, say, if you were building, I don't know, a concierge bot for the Rosewood here in London, like it would probably know the answer about the hotel's history. Not probably, definitely. Like you can play with that and see it, right? You could ask it about the history of any famous landmark, and it would know, right? So the question then becomes like, if it's remembered something about, I don't know, the parking information that it saw on a website, that's not up to date, but the model doesn't know, and you've given it like the universe of things that it knows about, but equally you've given it like, completely, you've told it to not supply answers to questions that it doesn't know the answer to, but it might not just listen to you. It's a pretty kind of like uncontrollable, wild energy that it has. And um, it might do what you expect, it might do something else. So it's kind of like just something that we need to, that you need to keep in mind when you design things with generative models.
Yeah, yeah. And then just, I guess on that exact note, how far off are we from seeing companies, especially enterprise companies with safety concerns and, like brands to protect and all of that, being able to incorporate generative into their workflows in a trustworthy way? Or what considerations would you give companies thinking about it?
Yeah, I think that like you see a lot of companies now like investing a lot in AI into using LLMs. There are different ways to use it, um, and one is to just kind of like use it as an assistive tool. You have the human there as a necessary filter, and that is just something that you can use, right? But when you look at it autonomously, say in the context of voice assistants or chatbots, it's up to the risk appetite. You can build very engaging, interesting prototypes very quickly, but equally, like putting something out there that you'll have absolute faith and confidence in is at the moment a bit difficult, right? There are other considerations, again, engineering related, about latency, quality of voice, all sorts of things, right? The safety around like hallucinations, potentially offensive language, like people tricking the assistant into saying different things and then kind of like calling your company out on it. So there is a lot to think about and unpack, and to use it kind of like safely and responsibly within like a broader kind of like a system framework is a thing that we spend a lot of time working on. It has huge potential, but it's kind of like the alternating current at the very start, right? And you can be an optimist about it and say, hey, this has the potential to be transmitted over hundreds of kilometers. It's how we light up the world, which is how it happened, right? If you're on the Tesla side of the equation, or if you're Thomas Edison, you can go around New York electrocuting sheep like he did to prove that Tesla's wrong. And if you want to do that with LLMs, you absolutely can, right? You can go and show that it will generate output that you might not want to generate right now, but very quickly we'll build the right kind of like control mechanisms around it, and we'll just learn to use them in a more responsible way. And the more important thing, I guess, is these models are improving at an astonishing rate. Like if you look at the jump from a GPT-3 to 4 in terms of just like things that could go wrong, it has reduced drastically. So I think it's safe to assume they will continue to make progress on the foundational model side in equal increments or maybe even higher. And if that happens, then you can just assume that alternating current becomes a lot more safe, a lot more quickly.
Yeah, love it. So I think you may have just invalidated my last question for you, which was around like how people who are listening to demos or they're interacting with bots that companies are saying are based on generative AI, how they are able to sort of tell if it truly is, if there are ways to sort of test that. But just given, what you just said, and like, feel free to hop in here, but like about the astonishing rate of improvement, it might be possible that the things that I get that get flagged for me to listen to. And it's just like, is this actually generative? I'm not hearing the latency, or it sounds too good to be generative. Like, is it? That might be a question that gets harder and harder to answer, even for folks like you who have been very, very close to the development.
Yeah, I mean, I think that there are like very specific ways of looking at the output of a voice assistant and understanding whether it's contextualized things around the way you ask the question, right? Mm-hmm. So, like, are you open on Tuesdays? Yes. Versus we are open Monday to Friday, 9 to 5, right? Like that's most definitely not a challenge, right? If the answer is a flat out yes, well, you're probably dealing with a more sophisticated model. So I think, if you think about just the levels of autonomy, say in autonomous driving or something like that, we can probably define a similar thing where, these, we should think about it actually, kind of like releasing just a set of different kind of like questions to ask around like how competent is this model, what can it do, right? And how does it deal with, yes or no kind of like questions, how does it deal with more complicated things, or just questions that have references in them that are not that obvious. But yeah, like I guess the more important thing is just like, is the end product good? Are people getting stuff done?
Exactly.
But yeah, generative will be a big part of like advancing these overall capabilities.
Exactly. Well, I love it. So it's almost like a business. You've got Turing tests and other types of tests of machine intelligence that are, maybe not exactly like we'd test human intelligence. Like maybe that world is sort of developing alongside, LLMs and generative and all of that stuff. But then from a business perspective, you've got another sort of test of the quality of a generative bot. And that is, does it help you? Is it profitable for you? Is this a good brand decision?
Yeah, I think like for enterprises, like a lot of people are investing a lot into, often these days we'll hear like about a mid-sized financial institution developing their own LLM, right? And frankly, that's a pretty big investment in a world that's changing so fast that, the jury is still out on whether they will actually have to fine-tune models for their own use cases. I think there's a large, impetus by cloud providers for them to do that because it will be an expensive operation that they can spend a lot of money on cloud compute doing. And, they'll get better models. Do they need those models? Do we absolutely have to do it that way? Do they need faster yet smaller models? That's a big trend, which it's definitely kind of like common sense logic. And if you build like a fine-tuned smaller model, it will run faster and cheaper. Absolutely, yes, it will. The question there kind of like goes back into the build versus buy, and kind of like at what level are you operating? Do you really need to do that? My intuition is that as we get towards better and better general models, and from all of the experimentation we've done, it's increasingly, and not just we had people write about this very, 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 very openly. Like there's a lot that you can do, for example, with untuned GPT-4, where previously you would have had to tune a smaller LLM to get to some level of performance. So I think if we can get these extremely large and more advanced LLMs to do all of the work, then we might not even have to have kind of like, private instances and stuff. But there are other sets of enterprise considerations around like data governance and, do you want your data accessed by OpenAI, Microsoft, or by Google, or do you want it on a private cloud? So, I think there are many buyers with different kind of like considerations, and some will have to develop those capabilities themselves. Some won't. I think regulated versus non-regulated will be very important.
Well, I think you just teased our episode topic for next week, which is a lot around the way that enterprises think about generative, the way that we think about building and incorporating generative into our stacks, into our customer experience. But yeah, I really appreciate the conversation today. Looking forward to the next one. Thanks, Nikola.
Thank you, Michelle.